In this video, we'll be looking at the Pythagorean theorem. So the Pythagorean theorem, as you might recall, is a theorem we use when we have right triangles. We use it to solve a missing side. And the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the right triangle, so the two sides that make the right angle, and then c is the hypotenuse. That's the side that you could draw an arrow through the right angle, right through the middle, and it'll hit that side. That's the hypotenuse. It's very important that you always find your hypotenuse, your c first. That way you know what's going to go by itself. Notice this is not a plus b equals c, but a squared plus b squared equals c squared. So let's try a few out here. Actually, let's look at the triples. Some easy ways to quickly figure out missing sides is use what we call Pythagorean triples. So let's say we have a triangle where 5 and 4 are here. Well, instantly we know our missing side has to be 3 because 3, 4, 5 is a triple. We know that if we see a 5 in the hypotenuse, because that's the biggest side, and a 4, that the other leg is 3. Vice versa, if we see 3 and 4 in the legs, we know the hypotenuse has to be 5. Same thing works for these other numbers, such as 5, 12, and 13. 13 and 12 here tells you that this must be 5. And same thing for 7, 24, 25, 8, 15, 17. I would memorize at least these basic ones. We also see the triples multiplied by scale factors. I can actually take this and I can multiply it by, let's say, 4. And I would have 12, 16, and 20, and that would still be a triple. So you could take any of these triples and multiply them by any scale factor. So let's look at some problems. Here we have 24 and 26 and x. So let's say you don't remember any of the triples and you just use the Pythagorean theorem. First, identify your hypotenuse. Well, the hypotenuse will be across from the right angle, so 26. So that means the other two sides go together. So x squared plus 24 squared equals 26 squared. X squared plus 576 equals 676. To move a plus 576, you subtract it. So x squared equals 100. How do you get rid of a square? Square root it. So x equals 10. So this side is 10. If you had recognized that 24 and 26 were both divisible by 2, you would have seen the numbers 12 and 13. 24 divided by 2 is 12. 26 divided by 2 is 13. And you remember the triple 5, 12, 13, but the scale factor was 2. So the x would have been 2 times 5, which is 10. Pause the video and try this one out. All right, so first identify your hypotenuse. Across from the right angle, you see 34. So it's going to be x squared plus 16 squared equals 34 squared. X squared plus 256 equals 20, no, not 2304, sorry about that. I believe that's supposed to be 1156. Sorry, let's erase that, 1156. We subtract 256 from both sides, of course. We get x squared equals 900. Square root it, x equals 30. Once again, if you divided both of these by 2, you would have seen 8 and 17. Remembering that 15 is a part of that triple, times 2 is 30. Before we move on to that, I want to actually change these numbers up and look at a different property here. So let's say that instead of 34 over here, that this is 6 and this is 4. So once again, identify your hypotenuse as 6. So x squared plus 4 squared equals 6 squared. X squared plus 16 equals 36. And how do you move a 16? Subtract it, so x squared equals 20. When you go to take the square root of 20, it's not a nice number, so you have to break it down. So factors of 20 are 10 and 2. 2 is prime. 2 and 5, prime, prime, 10, done. Circle your pair of 2's. So 2 comes on the outside and 5 stays inside. So x equals 2, square root 5. That's your answer. So if it's not a nice, perfect square, you have to break it down like we learned before. On a problem like this, you might look at it and be like, okay, that's not a right triangle. How do we solve it? Well, you can start by actually making a right triangle. And then you know that this is a rectangle, so this is x. And then since the whole side's 58 and this piece is 10, that leaves 48 right here. And then, of course, you can use the Pythagorean theorem to solve the rest, like we've already practiced. I'll just do the setup, and if you want, you can pause it and try to solve the rest. And then you'll get the answer, which, of course, here is going to be 14. On this one, you're looking at the same issue. 9 goes here, 9 goes here, so you can solve for this side and this side. And then here, you know that this is 8, so this is 10 because it's isosceles, and you can solve from this missing side using the Pythagorean theorem. All right, so we look at this question, and you should realize instantly that you have a 3 and a 4. If you have a 3 and a 4, you know that your hypotenuse will be 5, and this will be 8 because it's a rectangle. So 5 squared plus 8 squared equals x squared, because x is the hypotenuse. 25 plus 64 equals x squared. 89 equals x squared. And does 89 have a perfect root? No. Can it be broken down? No. So x equals the square root of 89. Let's do this one real quick. The diagonal of a square is 13 centimeters. So draw a picture. And we know square has congruent sides and right angles. So this will be x and this will be x. So x squared plus x squared equals 13 squared. How many x squares are there? Well, there's 2. And 13 squared is 169. To get rid of the 2, divide by 2 on both sides. So x squared equals 169 over 2. Now to get rid of the square, you take the square root. And when there's a fraction, you take the square root of the top and the bottom. So the square root of 169 is 13. We don't know 2. And if you remember correctly, we can't keep a square root in the bottom, so we multiply top and bottom by the square root of 2. So x equals 13 square root of 2 over 2 centimeters. Now that question is a little more complex, so you might want to review it and try to follow along with those steps. The last thing we're going to look at is classifying triangles as acute, right, or obtuse using the converse of the Pythagorean theorem. If c squared equals a squared plus b squared, we know it's a right triangle. So for example, let's say I gave you a triangle with sides 6, 8, and 10. And I don't tell you if it's a right triangle. I want you to figure out if it is. Then you would say, okay, what's my biggest side? Well, 10. So we got to see 10 squared. How is that related to 6 squared plus 8 squared? Well, that's 100. 36 plus 64, 100 blank 100. How is 100 related to 100? Well, they're equal. So this would be a right triangle automatically because this is true. Now let's say we give you a different set of numbers. 6, 4, and 5. Biggest side is 6. So 6 squared, blank, 4 squared plus 5 squared. 36, 16 plus 25. 36 blank 41. Well, how's 36 related to 41? Well, it's less than, so this triangle is an acute triangle. Make sure that you're squaring them and not just adding 4 plus 5. All right, so pause it and try these 4 out, and let's see how you do with them. All right, let's see how you did. So biggest side is 15 squared, blank 5 squared plus 12 squared. 225, blank 25 plus 144. 225 blank, 169. Well, it's greater than, so this is an obtuse triangle. Number 2, biggest side here, if you type in your calculator, will be 2 square root of 3. So 2 root 3 squared, blank root 5 squared plus root 2 squared. To square this, you always square the outside number and multiply it by the inside. So 2 squared is 4 times 3 is 12. So 5 plus 2. Square root of 5 squared is 5. Square root of 2 squared is 2. They cancel out. 12 is greater than 7, so this is also obtuse. And this one, biggest side is 12. 10 squared plus 9 squared. 144, 100 plus 81. 144, blank 181. It's less than, so this must be an acute triangle. And finally, on number 4, you should have actually seen that 5 plus 2 is not greater than 7, so this actually doesn't form a triangle. That's going back to first semester. It is important that you check to see if they form a triangle. The 2 smaller sides should be bigger than the third side. All right, so make sure to do your practice, and thank you for watching.